So we're building housings for the GPS units and creating pinouts so that we can connect these to various flight controllers. One of the things we've noticed is that the E-Flight GPS, which are the smaller GPSs on the bottom, they don't have any pinout documentation or references on the board as to what pin goes to what type of a signal. So we're going to basically use a voltmeter and figure the pinouts on our own, and of course the reference of standard, hoping that the signals are similar from the 3drrobotics.com GPS, which basically is a UART version only, does not have a compass connection, so it's missing the extra 2 wires that would typically go to the I2C bus. The pinouts for the 3DR are the plus 5 volt power supply, typically on the right hand side, or when it's upside down it's on the left, depending on how it connects to the flight controller. But it's almost always followed by split ground on the far left side. This is true for either a Pixhawk or a APM. So unfortunately the pinouts for the E-Flight are not in that order. Notice they go ground is on the top and then the 5 volt connection. So we'll basically create a 5-pin or a 6-pin connector. We've stripped the connector off of the present E-Flight GPSs, and we're going to reorder those to be consistent with the 3DR and standard printouts, so that we can connect these same boards to the same flight controllers. So what we'll do is, typically we've got the plus 5 voltage on the right hand side and the black ground voltage on the far left. On a 4-pin or a 5-pin, it's the same configuration, or a 6-pin, it just splits the difference. Immediately next to the plus 5 volt signal is usually the transmit line and then the receive RX line, and that's all that's necessary for a UART. So we'll make the same assumption that on the E-Flight you're going to have a transmit is the white wire, receive is going to be the yellow wire, and that would be consistent with the colors typical of then the compass that comes off of the E-Flight GPS, which would be the orange wire, typically would be the clock signal, and the blue wire would be the data signal, SDA and SCK. So we'll do that pinout and then do voltage checks, obviously making sure we don't burn anything out, rewire it so we can plug it in, and then build a housing so that these GPSs can fit into either air, ground, or sea, or model rocket type GPS transmitters. So we'll build a bulkhead for each and a mount for each in on shape, print those out, 3D print them, and then basically install them in whichever vehicle we choose to put a flight controller in at the time.